Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Zarif bin Azruniza. My metric number is KA23122, and I'm here to present about structural analysis of our report, and it is based off a wall-mounted folding table. So welcome everyone. Today we will be discussing about the concept of statics by analyzing the wall-mounted folding table. Let's dive right in. First, let's understand what static really is. So statics is the branch of physics that deals with the analysis of objects at rest or in equilibrium. It helps us understand how forces act on structures and how they can be balanced. So now let's take a look at our wall-mounted folding table, right here. This type of table is designed to be attached to the wall and can be folded when not in use. It is a convenience space-saving solution for small rooms or apartments. When analyzing the structural integrity of this table, we need to consider the forces acting on it. These forces include the weight of the table itself, any objects placed on top of it, and the force applied when folding or unfolding the table. The key to ensuring the stability of the table is to distribute these forces evenly. The table must be securely mounted to the wall using strong brackets or screws. This will prevent any wobbling or tipping when weight is applied. Additionally, the materials used in the construction of the table should be sturdy and able to support the intended load. The table should be designed with appropriate reinforcements and supports to handle the forces it will experience. By understanding the concept of statics, we can ensure that our wall-mounted folding table is structurally sound and safe to use. Remember, always follow the manufacturer's instructions and guidelines when installing or using any furniture. So thank you for watching, and I hope you found the analysis on the wall-mounted folding table helpful in understanding the concept of statics. If you have any questions, feel free to leave them in the comments below. So stay tuned for more. Thank you.
A very good day to you all watching this presentation. So my name is Netze Kyung and my metric number is KA23092. So I'm here to talk about the rigid body diagram of our project. So you will see from the rigid body diagram, we have split into 3 points. First is point A, point B, and point C. There are many forces in the structure. First is the weight of the table acting downwards. The second is at point A. At point A there are two forces, AS and AY. AS is the horizontal force and AY is the vertical force. At point B is also same with point A. In order to change the mass into weight, we use W equals to M times G, which is mass times gravity, and get this answer. The next step, we want to consider the moment about point A equals to 0. So we have horizontal force of point B. Okay, we say point S, point BS. BS times the vertical distance 0.75 and minus weight times the horizontal distance equals to 0. So from here we can get the answer of point B, BS. So next step, you use the principle of equilibrium. There is total of horizontal force equals to 0. So here is Fs equal to 0, and we have find out the As, the magnitude of As. The next step, we move to consider the moment about point C equals to 0, and substitute all this value into this equation. We can find out the magnitude of AY, which is the vertical force of point A. The last step is using the principle of equilibrium, which is total vertical force equals to 0, Fy equals to 0. So we have the magnitude of By find out. So there's through this step we can see that all forces ASAY, BSBY has been solved by using the rigid body diagram. So that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Anas Nasrin bin Raja Syahini, number ID KA19070. So I will present for the part central and center of gravity. The center of gravity is the point that the whole mass, the body is concentrated, and the center of gravity is directly proportional to the stability of the body. For example, the center of gravity of an object lower than its stability is higher, and the center of gravity of any object can be calculated by summing the weight of the body and dividing it by its origin. So this our free body diagram, and then we can separate the shape into 5 shapes. The first one is rectangular, and the second one rectangular, and third and fourth triangle, and fifth circle. So the shape, first we calculate the area and we determine the x and y, and after that we multiply x with area and y with area. So for the x bar, the formula is summation of the x multiplied by a and divided by summation of area. And for the x bar, we get 0.1034 meter, and for the y bar, the summation of y multiplied by a divided by summation of area, and we get around 0.44 meter. That's all from me. Thank you.